All right, this morning we're going to continue polynomial equation solving, and these are a little different than yesterday. So just to remind you at the top, if you want to change your look of your picture of your graph on your graphing calculator, here's some helpful tips at the top. And I'm going to pause this and I'm going to type this very first equation into the y equals button. So I paused, I typed the equation as it appeared in the y equals button, which is just this button right here at the very upper left. Once you have that typed in, go ahead and hit the graph button. And what we're looking for here are any places where the graph nicely goes through the x-axis. I have this really quickly. I did the zoom and then the number 6. I just typed the 6. And that gives you a -10 to 10 window. And this is where we'll ask you guys to look for zeros of the function. Now, if you're looking at the graph, you guys can see this goes through in two nice places, and then it goes through a third time, but I don't really know what that number is, so we're going to use algebra to solve that. Another quick thing I want to show you, if you hit second graph and you want to look at the table just to verify what points you think might be zeros, you're looking for where the y value is 0. So for this graph, I can see it right on the screen I have. You can scroll up and down here. But -5 is a 0, and also 3 is a 0, just by looking at the table. Alright, so -5 and 3. I already have 2 answers to my question. I need to get a third one. X to the third power as the highest power means I should have 3 answers. And you guys could see from the graph the other value was not the greatest. So let me translate these really quickly into linear factors. It'd be x plus 5 and x minus 3. So what I'm going to do here is I'm actually going to do synthetic division twice to break this polynomial down into completely factored form as much as I can. So I already know these 2 factors, and you can pick, it doesn't matter which one you start with. I'm going to start with the -5 just because I wrote that down first, and I'm going to write down my polynomial. So my coefficients 4x cubed, 1x squared, -74, and the 105. Bring down the 4. -5 times 4 is -20. If I add these together, 1 plus a -20 is -19. And I'm going to grab my calculator. -5 times -19, this is going to give us 95. And then if I do -74 plus 95, I get 21. And -5 times 21 is -105, which is what I want. I should not have a remainder. The 21's my plain number, -19 is my x, and the 4 is my x squared. Okay, now here's what I'm going to do. This is my result, 4x squared minus 19x plus 21. What I'm going to do is I'm going to further break that down by dividing in the other 0 that I saw. So the other 0 I saw was 3. The linear factor would be x minus 3. So I'm going to take our result. Both of these divide into the polynomial. So the x minus 3 will go into this also. But I'm going to use my result to divide. So I'm going to go ahead and write down 3. And then I'm going to write down the coefficients here. 4, -19, and 21. And this should be just like the last, should go in with no remainder. Bring down your first coefficient. 3 times 4 is 12. -19 plus 12 is -7. 3 times -7 is -21. Now, again, we should not have a remainder. That's what we got here. This is your plain number, and this is your x. So, by further breaking this down, all we have left is 4x minus 7. So the completely factored form of this polynomial would be what I have written up here. And then in this form, it's so much easier to see what our zeros should be. We already knew the -5 and the 3. And my third answer, if I set 4x minus 7 equal to 0, I would add 7 and divide by 4. So that third answer that didn't go through the nicest of numbers is going to be 7/4. So I got my 3 answers, -5, 3, and 7/4. Okay, I paused the video and typed in the next example. So go ahead and pause if you want to do that. And once you've got that polynomial typed into your y equals, I'm going to look at the graph and see if I can identify any real zeros from the graph. If this x to the fourth, I should have 4 answers in total to this question. So let me hit my graph button. And looks like all my zeros here are going to be real, but not all of them go through nice numbers. To me, this looks like -1 and 2, or sorry, -2 and 2. But let me just check real quick. I'm just going to hit second graph to look at the table. So -2 and +2. And then you guys can see the graph crosses in 2 other spots. I want to show you a quick feature here real quick. If you do want to see a better picture of the graph, if you hit the zoom button and you go down, it's number 0. It'll say zoom fit. If you hit enter there or type the 0, give you a little bit better picture of the graph, but I would recommend, because you can't really see the zeros very well the way that's laid out. It's trying to give you a really overall picture of the graph, but I would go back to that zoom 6 to look for the zeros, because that's going to be the screen where you'll be able to see those the easiest. But if you do want to see a little bit better picture of the graph, you can modify that if you'd like to. All right, so I'm going through -2 and I'm going through 2. The other 2 values, not super obvious. So I'm going to do the process we just did on the last question, where I'm going to divide that polynomial twice. So far in my factored form, I'd have x plus 2 and x minus 2 based on what I saw on the graph. So I'm going to actually divide both of those into the polynomial. It doesn't matter which one you start with. I'm just going to start with the -2 because that's the one I wrote down first. Write down the coefficients. If you guys prefer to do long division, you can do that as well. I'm just using synthetic because it's a little bit faster for me and it takes up a little bit less space. So bring down your first coefficient and then multiply, add here. -2 times 1 is -2. This will be -12 added together. -2 times -12 is +24 here. And I'm just going to add 19 and 24, which is 43. And that's going to give me -86. If I do 40 plus a -86, I'm going to get -46. And multiply 2 times -46, that's 92. So no remainder. This position's your remainder. Number x squared, and we actually have an x cubed here. Okay, now I'm going to repeat the process of the synthetic division, but I'm going to use the other 0 I hadn't used yet. I haven't used the 2, so that's where I'm going to start here. And just use the coefficients of your result. You're just breaking this down twice. So I'm just going to copy that 1, -12, 43, and -46. Bring down the 1. 2 times 1 is 2, and we're adding here. So this will be -10. -20, 23, and then 46. Okay, remainder would be in this position. We should not have 1 because these are factors. Number x squared. Alright, so since I've broken it down twice, this is the remaining factor here. So I'm just going to add that into my factored form. X squared minus 10x plus 23. Now from here, you guys saw I did have places the graph cross the x-axis, so I know my answers are real, but you're not going to be able to factor this quadratic. If you multiplied this back out, this would give you the polynomial we started with. It's just this is as far as this could be factored. Alright, so 2 of our answers are easy, -2 and 2. We saw those on the graph. What we're going to have to do from here is what we were working on yesterday, and do the quadratic formula. So I'm just going to go ahead and go through that real quick. It'd be opposite of b, so I'm focusing just on that set of parentheses. So it'd be +10 plus or minus square root 10 squared 4 times 1 times 23 all over 2 times 1. And then I'm just going to grab my calculator real quick. 10 squared minus 4 times 1 times 23. Actually, it's not too bad. This simplifies to just be the square root of 8. Okay, now go ahead if you want to use your factor tree, or if you want to do the biggest perfect square. I'm just going to do this quickly. Square root of 8 is going to break down to 2 radical 2. Don't touch the radical, but if the number in front of the radical and in front of the plus and minus symbol can be divided or reduced, you are allowed to do that. So each one of these is divisible by 2. This is going to be 5 plus or minus. These 2's would reduce to 1. You're not going to see that written in front. So then your other two answers, 5 plus the square root of 2 and 5 minus the square root of 2. Okay, now I have paused the video. I typed in this polynomial, so go ahead and pause if you need to, or rewind, and make sure you type in the polynomial. And then once you're ready, go ahead and hit the graph button. And I know I should have 4 answers to this question, but I'm only seeing the graph cross the x-axis in this window twice. So both of those look like nice numbers. This looks like -1 and this looks like -5. I'm just going to verify real quick by doing second graph to look at the table, and then I can confirm -5 and -1. Alright, so very similar to the last problem. Since I have 2 real zeros, I'm just going to do synthetic division twice. Let me come over here and start to write the factored form, x plus 1, x plus 5. So it doesn't matter which one you start with. I'm just going to start with the -1 because I wrote that first. Write down your coefficients. And I know some of these numbers look a little big, but we should not have a remainder when we get done here. So -1 times 1 is -1. Add these guys up, you get 5. -1 times 5 is -5. Add these guys up, we're going to get 64. -1 times 64 is -64. And now I'm going to grab my calculator here. No, I'm not. That's just going to be 320. And -1 times 320 is -320. And we get what we want. We don't have a remainder. This would be your constant, your x squared, and your x cubed. And both of these divide into the polynomial, so I'm just further breaking it down. So I'm going to take my result, and I'm going to use the other 0 that I haven't used yet. Again, you could do these in a different order. You could do the -5 first. The numbers would look different, but ultimately you would get the same factored form when you got done with the question. So bring down, we shouldn't get a remainder here either. -5 times 1 is -5. Now this is interesting because this actually is 0. -5 times 0 is 0. This is 64. And -5 times 64 is -320. So this one will actually be a tiny bit faster. So here's my remainder. Constant is 64. I actually don't have an x term, and then we have an x squared here. So whatever's left after I divided that twice, this would just be x squared plus 64. So I'm going to go ahead and add that back up. X squared plus 64. That is my completely factored form. You're not going to break that down any further. That is not a difference of squares. We'll talk about that in 2 seconds here. My answers are -1, -5. We saw that on the graph. Now remember, I'm going to just set this equal to 0. So x squared plus 64 equals 0. Subtract the 64. This is going to have a nice answer, but it's going to be imaginary because when I subtract that, I end up taking the square root of a negative. So 1, 2, and this is going to be 3, 4. I should have 4 answers to the question. Square root here is going to be plus or minus 8i, and that's why we didn't see the graph cross in any other place on the calculator screen, because the other 2 answers are imaginary. X to the 4th means 4 answers, so -1, -5, that's 1, 2, and then 3, 4, positive 8i, and negative 8i.